Our intercept and factored form that we saw in our exploration isn't actually part of our textbook, so I'm going to call this 4.5 halves, because 4.2.5 sounds weird, and it's between section 2 and 3. Anyway, and fractions are better anyway than decimals, so we're calling this 4.5 halves. I'm going to make a little chart here for us to just kind of review the forms that we've learned so far for quadratic functions, and also to get us going with our intercept and factored. So in my little chart here, I have a column for what form we're working with and the general equation for each one, and then also what we can easily see. With our vertex form, remember this is really like our transformation, so we can easily see our vertex. And circle our parts that tell us our vertex, H. Okay, give us our vertex. Standard form, y equals ax squared plus bx plus c. We can easily see our y-intercept, and that's our c value. In our intercept form, or factored form, however you want to call it, our equation is y equals a times x minus p times x minus q. And this intercept form lets us easily see the x-intercepts of our parabola. And those x-intercepts are p and q. Okay, let's go through an example of graphing a parabola that's in intercept form. And we will graph our parabola y equals -2 times x minus 4 times x minus 8. Looking at our chart again, I know that this is intercept form because I have my two sets of parentheses that are multiplied together. This p value and q value tell us our x-intercepts. Or better yet, our x-intercepts happen when each factor equals 0. So we have an x-intercept when x minus 4 equals 0, and we have an x-intercept when x minus 8 equals 0. Okay. Then we can add 4 to each side, add 8 to each side here. These are our x-intercepts. These are where our parabola is going to cross our x-axis. So at this point, let's go to our graph. And we won't need to go very far to the left, but since we have to go all the way out to 8 on our x-axis, we'll need a little bit there. Okay, let's plot our x-intercepts at 4 and at 8. And then we'll pause and think for a second. Okay, remember that parabolas are symmetric, same on both sides. So if I have an x-intercept here and an x-intercept here, these two x-intercepts have to be the same distance away from my axis of symmetry, which means my axis of symmetry needs to be right here on the line x equals 6. Okay, my axis of symmetry has to be halfway in between, which tells us the x-coordinate of my vertex. The only thing I don't know is the y-coordinate of my vertex. So I know this much, I just don't know my y-coordinate. To figure out our x-coordinate of our vertex, to figure out our y-coordinate of our vertex, take the 6 and plug it into our equation. y equals -2 times 6 minus 4 times 6 minus 8. -2 times 6 minus 4 is 2. 6 minus 8 is -2. -2 times 2 is -4. Times -2 is +8. And I did not give myself enough room here. But +8 is my y coordinate of my vertex. So my vertex altogether is 6, 8. And let's plot this point. Way up here, running into my equation a little bit, but that's okay. Now, one other thing I need in my graph, I need one more point. Because keep in mind that we still want our vertex and then 2 points on either side. So an easy x value I could use to plug in one past my vertex would be plugging in 7. So I'm going to take 7 and plug this into my equation. -2 times 7 minus 4 times 7 minus 8. 7 minus 4 is 3 times -1. -2 times 3 is -6 times -1 is +6. So 7, 6 is another point on my parabola. Right here. And same on the other side of my axis of symmetry. Now I have enough points, I can connect the dots. And we have our parabola. Don't forget to draw those arrows in.